Hi, I am Revathi, Assistant Professor, Department of EEE, SNS College of Engineering. In this lecture series video of electron devices and circuits, today's topic is feedback amplifier. So, feedback amplifier contains two components, namely feedback circuit and amplifier circuit, where feedback circuit is essentially a potential divider consisting of resistance R1 and R2. The purpose of feedback circuit is to return a fraction of the output voltage to the input of the amplifier circuits, where the in the feedback amplifier circuit diagram, where the input signal is given to an amplifier, where the output side it is given as a feedback to, again it is turned over to the input signal, where both negative feedback and positive feedbacks are in amplifier circuits. Negative feedbacks return part of the output to oppose the input, whereas in positive feedback the feedback signal aids the input signal. AF, a closed loop gain of an amplifier, open loop gain of an amplifier. If a feedback signal AF is connected in series with the input, then VI that's equal to VS minus VF. For a negative feedback, beta A greater than 0. For positive feedback, beta A less than 0. Advantage of negative feedbacks can reduce the gain of an amplifier, but it has many advantages such as gain stabilization, reduction of nonlinear distortion and noise, control of input and output impedance, and extension of bandwidth. Gain stabilization, therefore, percentage changes in AF due to variation in some circuit parameter is reduced by 1 plus beta A times compared to without feedback. So advantage of negative feedback, reduction of nonlinear distortion, a open loop and closed loop gain, wherein bandwidth extension. So basic feedback topologies are depending on the input signal, voltage or current to be amplified and form of the output, voltage or current. Amplifier can be classified into four categories. Depending on the amplifier category, one of four types of feedback structures should be used: voltage series feedback, voltage shunt feedback, current series feedback, current shunt feedback. Where voltage series feedback acts as an voltage amplifier, current shunt feedback trans resistance amplifier, current series feedback trans conductance amplifier, current shunt feedback current amplifier. Here, voltage refers to connecting the output voltage as input to the feedback network. Series series refers to connecting the feedback signal in series with the input voltage. Shunt refers to connecting the feedback signal in shunt parallel with an input current source. Where the feedback topologies are given in the circuit, where the current parallel current feedback, parallel voltage feedback, series current feedback, and series voltage feedbacks are there. The output resistance of the amplifier and output resistance of the feedback current are in parallel, hence effective output resistance of the feedback amplifier will reduce. Similarly, overall input resistance of the feedback amplifier will reduce due to parallel connection of amplifier and feedback resistance. Effective output resistance is also small compared to the resistance of amplifier without feedback. Hence, the less voltage will drop at R naught efficiency and most of the voltage occurs at RL. Hence, output current will behave like a voltage source. The voltage shunt feedback current behave like a current controlled voltage source. Where in voltage series feedback topologies, input resistance of an amplifier and feedback networks are in series, hence effective input resistance will increases. Output resistance of an amplifier and output resistance of the feedback circuits are in parallel, hence effective output resistance of the feedback amplifier will reduce. Where in current series feedback, output resistance of an amplifier and output resistance of the feedback circuits are in series, hence effective output resistance of the feedback amplifier will increases. Where in current shunt feedback, effective output resistance of the feedback amplifier will increase, effective input resistance will decreases. Voltage shunt feedback amplifier forms a negative feedback. is the right answer. A value of feedback resistor and resistor connected in series with the input signal sources are equal to 10 kilo ohm and ohms and 3.3 kilo ohms. Calculate the closed loop voltage gain equal to minus 3.33. Write the formula for closed loop voltage gain of inverting amplifier with feedback using open loop voltage gain and gain of feedback circuit. Thank you.